How are choppers and PWM related in electrical engineering? Imagine controlling the speed of a motor or adjusting the power flow in a renewable energy system with just a flick of a switch. That's where the magic of choppers and pulse width modulation comes into play. In electrical engineering, a chopper is a device that converts a steady direct current voltage into a variable direct current voltage by rapidly switching the power on and off. This switching happens at very high speeds, often above 20,000 times per second, to make the change smooth and efficient. Pulse width modulation, or PWM, is the technique used to control how long the switch stays on during each cycle. Think of it like a blinking light that can stay on longer or shorter in each blink. By adjusting the duration the switch is on, PWM controls the average voltage and current delivered to a load, like a motor or a battery. When the switch is on longer, the motor gets more power. When it's on shorter, it gets less. The connection between choppers and PWM is direct and essential. The chopper uses PWM to regulate the output voltage. It does this by changing the duty cycle, which is the percentage of time the switch is on during each cycle. If the duty cycle is 50%, the switch is on half the time and off half the time, giving an average voltage that is half of the input voltage. Increasing the duty cycle raises the average voltage, and decreasing it lowers the voltage. This method allows precise control of power, which is especially useful in renewable energy systems like solar or wind power, where you want to match the energy output to the load. It's also used in electric vehicles and industrial drives to control motor speed efficiently. The rapid switching and PWM control help reduce power losses compared to traditional linear methods, making systems more energy efficient. In practical terms, the chopper switching is guided by the PWM signal. Sensors monitor the current and voltage, and the control system adjusts the pulse width accordingly. This feedback loop ensures the load receives the right amount of power, regardless of changes in the system or load conditions. The high switching frequency also helps minimize noise and makes the operation smoother. So, in essence, choppers relying on pulse width modulation as their main control strategy. PWM provides the precise, adjustable pulses needed to turn the chopper switch on and off at the right times. This combination makes it possible to efficiently control power in many electrical systems, from renewable energy sources to electric motors, ensuring they run smoothly and effectively.